And end of 2022, the White House asked ASHRAE to develop a standard that deals specifically with infectious aerosols. ASHRAE took on the challenge, and in the period of warp speed, 6 months, they were able to publish the standard and approve it. It happened in June of 2023. It's called ASHRAE Standard 241, Control of Infectious Aerosols. The purpose of the standard is to establish minimum requirements to control infectious aerosols to reduce the risk of disease transmission. Two of the groundbreaking features of the standard, one of them is the infection risk management mode. So you don't need to do a high IQ all the time for consideration of cost and energy. You can define an infection risk management mode, basically have your building ready for this IRMM mode. When conditions warrant, you turn on your building to this mode. The second one is called equivalent clean airflow, also to be provided during infection risk management mode. And this equivalent clean airflow is basically the target of clean air. It's basically an airflow quantity of clean air per person.
In fact, for a classroom, which I've highlighted, the CDC recommendation is about double the historical ASHRAE 62.1 target, and the ASHRAE 241 standard is more than triple the previous ASHRAE 62.1 target, up over 9 equivalent air changes per hour. Now, here's the first problem. Most all HVAC systems are not going to be capable of doubling or tripling the ventilation air that they're bringing into a building without a major system upgrade or replacement.
Our system is old, and then they don't have the capacity desired to use with the new filters. So it's the big challenges. So the impact from the filters, we see we have a lot of fan motor fails, the bell broken, and the filters affect to the static presses, because we don't have enough people to do a lot of PMs, improving the outdoor air quality without the increase the system load is the keys. It's so important because we cannot increase the system load.
And anytime you've got to do a major HVAC system upgrade or replacement, that's going to be extremely costly, and it might not even be possible.
And the catch is, it's not only about outdoor air. Outdoor air is a component, but you can achieve this clean air by combination of outdoor air, filtration, air disinfection. And this really allows for flexibility to consider factors such as first cost, ongoing cost, energy use, and carbon reduction.
We're talking about a well-studied technology that we understand when it comes to Upper Room GUV. Upper Room GUV have multiple evidence-based studies dating back over 80 years that they are effective and safe for humans when effectively installed and commissioned. The big idea is that we're creating a zone outside of the occupied spaces where there are no humans, but that's where a lot of respiratory pathogens are dwelling. We're addressing the pathogens where they're created, and we're not relying on a recirculation of air or other controls outside of the room space in order to address the pathogenic spread.
In 1993, the United States was undergoing an epidemic of drug-resistant and multi-drug-resistant tuberculosis. And it was fueled in part by the HIV/AIDS epidemic, and we had no effective drugs to treat AIDS. At that time, I was appointed director of Philadelphia's TB control program, and in 1993, CDC recommended Upper Room GUV as the primary engineering control, not ventilation and filtration, because the goal is to prevent infection in the room.
Second problem. If the systems were capable of doubling or tripling the air that we're bringing into buildings, that's air that must be heated or cooled, and it's going to result in a potentially massive increase to building energy use and carbon emissions.
This is a relatively low energy technology, as opposed to a lot of situations where we're massively increasing the amount of outdoor air just to dilute the pathogens we have in our space. We're taking a significant energy penalty for having to heat and cool the majority of that air as we're bringing it in. And that in-room effectiveness does not depend upon complex system conditions. It doesn't depend upon filtration. We are not relying on building controls, fan speeds, dampers. In fact, in a relatively short time, we can design, install, commission, measure, and know that we have effective in-room control in an intermediate process.
Technology that you could implement with such speed and then have such confidence in it. One of the things that I would get a lot of questions about is like, is this effective? Is this safe? And so with John and Plan LED support, I was able to educate our community, our school board, teachers and parents that we were actually doing everything we could. And in my opinion, better than we were ever doing it before, providing a safe environment for our students and staff.
You know, there was a recent study that's been published by Boston Children's Hospital. They found the result that 70% of COVID transmission started with children.
I have the confidence in what we did to solve that very specific problem. And now moving forward, anything else that comes at us, right? Regular cold and flu season or the next thing that might come our way. We have confidence in that. So cost-effective peace of mind is huge.
The good news here is that we have the tools and technologies available to us. We don't have to invent something new. We've got Upper Room GUV and some of these other in-room solutions that can help us deliver clean air, reduce disease transmission, improve education outcomes, while achieving our energy and climate goals.
So the opportunity there is that since the dosing, the irradiation, and the safety are relatively well measured and understood, we can know that we have that mostly right now and move forward to implementation.
Improving indoor air quality should not come at the expense of our planet and should not come at the expense of our energy reduction goals and carbon emission also reduction.
For funding, the Department of Energy's Renew America Schools grant program is going to be opening up a new round of funding applications in spring 2024. And so this is going to be a great opportunity to put forward an Upper Room GUV project for funding. The funding from the last round was a lot, of $178 million that went to 24 different school districts. So I hope that some of you might consider applying for this next round.
The only feedback I've gotten has been positive from staff. And then, the community that sees it in the common spaces around the school, just educating them on what it is. And once they understand it, they're excited about it.
So as you see from this graph, it's feasible to comply with Standard 241. It's feasible to prepare for the next pandemic, the next outbreak, the next endemic. You can do that as I show you here with UVGI and, same or higher filtration efficiency, depending what you're going to. Now, there are other approaches, but for the purpose of this presentation, I'm just showing you the benefit of UVGI and Upper Room GUV.